All right, so for this question here, we are talking about factorial equations, and your first step is to simplify that left side, okay? We've done a number of examples here this class on this. So what you have to remember is that this factorial symbol means that we take whatever this value is, this number, this expression, whatever it is, and we multiply that times 1 less than that, times 1 less than that, times another 1 less, and so on. So we have to try and expand this out, so rewrite this a little bit so that we can start to simplify this side. So minus 1 here becomes n plus 1. All right? And then as we subtract one more, this becomes an n here. And then we see, hey, I can write factorial right here because I have n factorial on the bottom. Okay? And then equals 6. All right, so this expansion or this simplification of this side is super, super important. That's where you need to start all the time. Okay? It doesn't matter if this bracket is inside or outside, doesn't matter. All right, so once you can simplify that, then you can kind of see that, hey, n factorial, gone. So I now have n plus 2 times n plus 1 equals 6. So we got to simplify this some more, so we multiply this out. So when you have a binomial times a binomial, do you remember you use the FOIL method? That's first terms you multiply. So the first terms, we multiply those, we get n squared. And then you move to the outside terms, so that's n times a positive 1, that's plus n. Then the inside terms, so 2 times n is plus 2n. And then the last terms, so that's 2 times 1 is positive 3, so you go plus 3 equals 6. So we have n squared, right, plus 3n, when you gather these like terms, plus 3 equals 6. Now in order to either factor and use the zero product principle or to use the quadratic equation, you have to get everything over to the same side, on the same side of the equation. So this is n squared plus 3n. I'm going to subtract 6 from both sides, so that's 3 minus 6, negative 3 equals 0. So this is the quadratic that I'm focused on here. Okay, this is a quadratic. You cannot isolate for n, it's in two different terms, right? So you're going to have to use the quadratic. Okay, so we have a 6 over here. I subtracted 6 to get this negative. So the zero product principle says that I am going to look for factors of negative 3 to get to 3, n squared, n and 2n and 3. Okay, just looking okay with you guys? Okay, I thought something looked a little funny here. 2 times 1, I think I said it. I'm not sure if I said it incorrectly. But 2 times 1 is 2, not 3. Okay, and so this is a 2. We minus 6, that's a negative 4. Okay, all right. So this should be a negative 4. Something didn't look quite right there. So in factoring this, all right, so we have now n. We're going to have n and n as the first terms in our factoring. We need to look for factors that multiply to negative 4 and add to positive 3. Okay, so that looks like it's going to be plus 4 and minus 1. Those multiply to negative 4 and add up to positive 3. Okay, so if that's the case, then I have n equals negative 4 and n equals positive 1. How's that look? You guys following along here? Okay, jotting that down. Write this down. Okay, you're gonna have to know how to do this, so make sure you have this down. Okay, so those are my two options. Let's, for those of you that used the quadratic formula, x equals negative b plus or minus root b squared minus 4ac all over 2a. So that one you're going to have memorized, or you're going to have on your cue card or something. So, and we have, of course, n as our variable, so we can use n here. So n equals, b is 3, so negative 3 plus or minus, oh, that just disappeared on me, the square root of 3 squared minus 4 times 1 times c is negative 4, all over 2 times a is 1. So you plug in your values there. Let's see what that gives us. Negative 3 plus or minus the square root of 9 plus 16, because that's a negative times a negative there, all over 2. So negative 3 plus or minus the square root of 25, all over 2. This is going to be negative 3 plus 5 over 2, and negative 3 minus 5 over 2. So negative 3 plus 5 is 2 over 2. And negative 3 minus 5 would be negative 8 over 2. So this is going to give us an n equals 1 here and a negative 4 here. And that's what we got over on this side too. So you're going to have to learn how to do at least one of those two ways to find your n values. And then you're going to have to figure out which one is okay and which one is not. So we cannot have a negative 4 factorial, right? So this one we have to reject. This is our answer. Sorry, n equals 1. And we probably should check that. So if we were to check that, maybe I'll leave this question up. If we were to check that to negative 1, make some space here. Then, I'm sorry, positive 1. So then we go, our check would be positive 1 plus 2 factorial over 1 factorial equals 6. So that's 3 factorial over 1 factorial equals 6. 3 factorial we know is 6. 1 factorial is 1. And so 6 over 1 equals 6. That is true. All right, so that's 11. That's 11B from your 4.2 assignment there, from questions that you're going to have to do. So that's the toughest part of this lesson for sure. Okay, and yeah, we fixed a little error here that we did halfway through. Any questions? Any questions on that? No?